So I think it's similar to the question we did the other day. Remember one another day we did, and it came to be zero. I think it's something like that only. Um,
You want to say the wheat stone bridge, the balanced
yeah,
wheat
yeah,
stone
yeah,
bridge,
yeah. I think it's that
because
only.
there are five sisters, one, two, three, four, five.
That is same kind of.
But
That's the only
there,
reason.
okay, the only reason the balanced wheat stone bridge, whenever you see the five resistors, you will say zero. Okay. Any other any other good logic?
Um, no, sir. I'm just doing it based on pattern recognition, sir.
Okay. Please see. This is the so simple. See, balanced Wheatstone bridge is very high concept with respect to this question. Very high. Please see.
I see.
You know,
Okay.
to flow to flow the current through any component, how many wires you need?
How many wires you need?
You need two wire, right?
Yes.
Whenever you take the electricity connection from government or from anywhere, you take two wires, isn't it?
Yeah.
In one way, current will come, and in another way, current have to be returned, isn't it?
Hmm.
So suppose this is a network, this is a network, and you have connected something here. So suppose from this side, from left side to right side, suppose there's some current is going. So the
Hmm.
same current must be returned to the same circuit or not? Please think.
Yeah, it must.
You can verify this. We can verify this by mathematical calculation also. But
Yeah.
if you know this one, that through a single wire, how a current can flow? If there's some current flowing through left to right, there must be some current from returning in this way, isn't it?
Mm.
Otherwise, we can verify this through mathematical calculation. Tell me, do you know this? Do you agree that its current should be equal to zero because there is no path for returning? It should have. Now, if you connect these two points, then there will be some current in this, and you can find it easily,
Yeah.
right? Are you getting? So its answer
Mhm.
should be 0 ampere. Have you
Yeah.
understood? Any doubt?
I think
But
this one, yeah, I understand.
but this question can be discussed for voltage also. Now suppose I want to find the voltage or potential difference between these 2 points. Suppose this is the point A, this is the point B. So I want to find the potential difference between A and B. It means the potential difference between the across the 10 ohm resistor. We know that the current through the 10 ohm resistor is zero. So does it mean that the voltage is also zero?
What did you also say? No, not necessarily.
Not necessarily. Exactly. See, current is zero. That is, you may have the open circuit. See, for open circuit, current is zero, but voltage may exist.
Mm.
Similarly, for short circuit, we have uh, voltage as zero in the short circuit, potential difference is zero, but current may exist,
Yeah.
right? Okay. So in this case, we have current at zero, so we have to find the voltage. So we cannot say with the logic that, see, V is equals to IR. Can we apply this logic? V is equals to IR. So since you are saying, sir, the current is zero, so a zero into R, so voltage should also be zero. Can we give this argument for voltage to
No,
be zero? Why?
no. Uh, wait,
It's,
can we? We can though, right? No?
basically, I'm trapping you. Okay.
Yeah.
See?
It's
So
yeah.
I is zero, R is something, so V should be zero.
Yeah, uh,
Yes.
mm,
So in that case, see, that's why I'm saying that's for that case, I have given you these two conclusions. You will explain that, sir, see, I is equals to zero. It doesn't mean that it has zero voltage because this may be a condition of open circuit also.
Yeah.
It may be a condition of open circuit also. And this V
Yeah.
equals to IR is basically circuit parameters relation,
I
right?
see.
So now I have to find what should be the voltage difference across point A and B. So I cannot say blindly zero, right?
Yeah.
So how we can calculate this? That's the point.
Mm.
Okay. So for that, I should give you some other information. Okay. Okay. Can you find the voltage across this 2 ohm resistor in this left network? Can you find the voltage across this 2 ohm resistor? Similarly, can you find the voltage across this 1 ohm resistor in the right network? So in this left side network, the voltage across 2 ohm will be, can you find quickly?
Cross 2 ohm.
Yes.
Yes. How much is it?
See, in this left network, if we assume only this one, current will flow, right? So I
Yes.
want to find the voltage or the potential difference across this 2 ohm resistor. Can you find it quickly? We can
Shasta.
apply here the voltage
Yeah.
division rule.
Yeah.
The voltage division rule, so it should be V across 2 ohm should be equals to 2 upon 3 into 3. So this should be 2 volt. So here it should be 2 volt. Similarly,
Mm.
from the right network, if you find the voltage across this, so voltage across 1 ohm should be equals to 1 upon 3 into 3. So it should be 1 volt. So it should be 1 volt. Now, suppose the voltage across AB is Vx, right? And I
Mm.
can assume any polarity also. And I have assumed this is the plus and minus. See, one more thing I want to discuss that you know how and why I have given these polarity, why I have given this as a plus and this as a minus. The polarity is very important. See, I'm giving you some next level concept. So, okay. So this is positive. This terminal has to be positive for sure because the current is flowing from this way. And we know current flow from the high potential to low potential. So that's why I have given this as a plus sign and this as a minus sign. Similarly, in this way, if you see, the current will flow from the high potential to low potential. So that's why
Mm.
I have given this as a positive sign and this as a negative sign, right? And for this Vx, I have given it as an arbitrary sign. This should be positive and this should be negative. You can give any terminal sign here. Is it okay till here?
Yes.
Now I am going to explain you the Kirchhoff's voltage law, or we can say the Kirchhoff's loop law. Have you heard? I think you must have heard it. Loop law. Is it okay?
Gotcha.
Okay. So what's a loop law? So
Um,
okay. Let me explain. I am explaining.
yeah.
So the
Okay.
loop law tells that in any loop, in any loop, if you if you move across all the devices, all the components, and if you add the voltage drop, it should be equals to zero. Okay, so you can see, sir, where is the loop? So, okay, the second concept is your loop is not necessarily, it should be a physical loop, it should be a connected loop. You may have a loop in hypothetical way. For example, I'm connecting this as a loop. Please see, it means here to here, here to here, here to here, and here to here.
I see.
Why I can take this? See, this is also negative, this is also negative, this is also 0 volt. See, this is also grounded level, and this is also grounded level. So ideally,
Mm.
conceptually, they are at the same terminal, they are connected conceptually. Are you getting my
Yeah,
point?
yeah. I kind of, yeah.
Yes. S- Okay. So I am assuming this as a hypothetical loop. They not connected physically, but I can take this. Okay. So suppose I am moving in this way. So, okay, we have to add all the voltage algebraically. So what you have to do? Suppose we are starting in this way. So you you came across this 2 volt. So what terminal sign you got first for 2 volt? Negative. So you should write
Mhm.
negative 2.
Negative. Okay. Yeah.
Okay. Then in your rotation, you are getting what? Positive Vx. So you
Yeah.
should write plus Vx.
Hmm.
Similarly, in your rotation, what you are getting? Plus 1 volt. So you should
I
write
see.
plus
Plus.
1 and it
I
should be
see.
equals to 0. So
Okay.
Vx minus 1 should be equals to 0. It means Vx should be equals to 1. Is it okay? It means
Oh.
yes, there is a potential difference between A and B of 1 volt. Still, there is no current. Is it okay?
Hmm.
Now, if you are thinking that what will happen if I give a reverse polarity here, if I give this plus minus if I change it minus to plus, no problem. See, suppose you have assumed this initially we have assumed this plus minus and we got the positive answer. It means whatever we have assumed arbitrarily, that
Hmm.
is matching with the real situation. If
I
you are
see.
assuming this negative and positive, then obviously you will get the minus one. That indicates that your assumed polarity is basically opposite of the real situation. Okay,
Real.
so verify this. We will do this one also. Okay, please start with this loop. So again, I will encounter first the negative 2. So I should write negative 2. Then what you will encounter? This negative Vx. So
Yeah.
you should write this minus Vx.
Hmm.
Then you will encounter plus 1. It should be equals to 0. Please solve for Vx. What you are getting? You should get Vx equals to minus 1. Please check. So this minus is telling you that, oh, your assumed polarity is the opposite. Either you can reverse your polarity that this is the positive, this should be negative, or you can tell according to this polarity. If the question asks by giving this polarity sign, suppose in the question they have already defined their polarity, then your answer should be minus one, or otherwise you can say in a positive way also. Have you understood this KVL, Kirchhoff's voltage
Yeah.
law, or this is called the loop law? I think you can learn this very easily. So that's why I have explained this related to this question, and this is a very conceptual concept.
Hmm.
Okay,
Conceptual. Okay.
any doubt?
Oh no. So far so good.